Greetings, peeps. We're looking at Newton's laws and forces. So Newton's laws of motion and forces. Newton, my Newton hat. What do you think? This case involves a horizontal net force. We're trying to find the net force horizontally. From the net force, we're going to try to determine what the acceleration of the object is in the horizontal direction. This is known as a crate style problem because, well, we have a box. It's a crate. And it's resting on a surface, and we've got various forces involved that are acting on this crate. So let's look at them. I've taken the liberty of drawing a free body diagram. This is something that you will have to do for various problems to create, but I've done it here for you. And I've also established a coordinate system. To the right is the positive direction for X, up is the positive direction for Y. And I've also labeled the forces accordingly, and their magnitudes are down here. The vector arrows that represent the forces ideally would be to scale. Like, for example, force applied, FAP, is 20 newtons, and it would be longer than force resist by twice as much if I were to draw this to scale. But we'll just look at the magnitudes here, and what's important here is the direction, and trying to use the free body diagram to actually write our equations in order to uncover the net force and the acceleration. Okay, so with that, we see that F applied is in the positive direction, F resist the negative direction, and F normal points upward. The force of gravity, known as weight, points downward. It's equal to mg. Well, as it turns out in this problem, this is completely horizontal here. We don't have any motion up or down. What's happening is that the force of gravity, the weight of this object, is pushing down on the surface, on the floor, and that floor, due to Newton's third law, the action-reaction of force pairs, is going to create a normal force that is opposite in direction and supports the crate on the floor. It's the supporting force. So what I'd like to do is just quickly calculate this, even though it doesn't have any effect on the horizontal piece, but it'd be nice to do. So the force of gravity is equal to the mass in kilograms. Remember, we're using the MKS system, so kilograms will be our standard for mass. Finally, we get to use mass in calculations where we haven't done that before. And the force of gravity is mass times the acceleration of gravity, g, which is 9.8 meters per second squared in the negative direction. So the force of gravity is going to be 5 kilograms times negative 9.8 meters per second squared for a force of negative 49 newtons. All right. And as it turns out, the normal force has to respond to anything that's on the surface. Because 49 newtons is pressing down on the surface, 49 newtons is going to be responded, the action-reaction pair. So it pushes back with 49 newtons because all forces come in pairs, as Newton's third law says. So this is also 49 newtons, but it's positive. All right. And so that's all set. And now we'll look at the horizontal piece. And for that, I'm going to use Newton's second law equation that says F net, force net, is equal to mass times acceleration, in this case in the x direction. So we're going to go with m times ax, a sub x. So force net is m times ax. Well, the net force is also the combination of all forces in a given direction. The vector combination, meaning that we have to add up all those forces, and whatever is left over, which means net, is going to be the net force. All right, well, that kind of makes sense. So here we've got the force net also equals force applied pulling to the right, so it's FAP. And in the negative direction is F resist. Now F resist can be any type of force like friction. It could even be someone holding the crate back. It could even be, well, possibly air resistance, something like that. But we're going to get into the detail of what it could be later on, particularly friction. But right now, we'll just consider it to be something that is preventing force applied from using its full force to accelerate this box and change its state of motion. So it's Fap minus F resist. And that's it. These are the only two forces acting in the horizontal direction. So I've got F net from Newton's second law and F net from the sum of all forces in a particular direction, and whatever's left over works out. The fancy way of writing that, of course, is that the sum of the forces, in this case the x direction, is equal to mass times acceleration. All right, that's the fancy way of doing it. Well, now that I've got this equation over here, I can figure out what F net is and then solve for A, okay? Now AX is simply F net over M for mass, that's it. So it's an easy equation, and the F net part will come from over here, where we've got force applied and force resist. We would substitute that into here for the final equation. So AX, if I were to write it down in total, which I will, AX equals force applied minus force resist over M. That's it. Now, if we want to know what force applied minus force resist is, we could just plug in the values. And so let's do that. We have 20 newtons minus 10 newtons for force resist, 10 newtons, and that alone gives us the net force, which happens to be 10 newtons, and we divide that by mass to get the acceleration. Well, what is the mass? The mass is 5 kilograms. So let's write that down over here. We have 5 kilograms. And now I'm going to get out of the way of the board for a second so that you can pause it and see what's up here if you need to take notes. Haha. How's that? I'm learning what you guys need. So here we go. Numerical form. 20 minus 10 is 10 divided by 5 is simply 2. So our final answer here is 2 meters per second squared for AX. So this is a pretty simple problem, the way it's organized. In the future, we may have more forces acting on the crate. We may have forces at an angle acting on the crate, which means that some part of that force will be horizontal, some part will be vertical, and we'll have friction. So this basic problem becomes a little more complex later on, but the structure is still the same. The ideas are still the same, where we would take all the forces in a given direction, evaluate it for the net force, include that in an equation that deals with the acceleration, and plug in our values at the end, and here we go. And of course, the very final thing which you would do is write a paragraph. Now, we've evolved where there's probably enough information to write an entire summary paragraph of what's happening, and that would be the final task. So in this case over here, we have the crate, we have the forces, and we would describe what's going on in terms of the physics, and that would be a job for you. All right, the next type of problem we're going to do is a vertical problem known as an elevator problem. But that wraps it up for horizontal net force and the crate. Awesome. Morad, out.